Hello everyone, my name is Viraj, and today we'll be looking at the 29th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So moved on to my sheet and I have ticked off 1029 problem, Johnny and ancient computer. Let's see this. Johnny has found an ancient broken computer. The machine has only one register, which allows one to put their one variable. In one operation, you can shift its bits left or right by at most 3 positions. The right shift is forbidden if it cuts off some ones. So in fact, in one operation, you can multiply or divide your number by 2, 4 or 8, and division only is allowed if the number is divisible by the chosen divisor. Formally, if the register contains a positive integer x, in one operation, you can replace it by x dot 2, that means x into 2, x into 4, x into 8, or x by 2 if x is divisible by 2, x by 4 if x is divisible by 4, and x by 8 if x is divisible by 8. For example, if x is 6, you can do one operation and you can replace it with 12, 24, 48 or 3. Value 6 isn't divisible by 4 and 8, so there is only these 4 variants of replacement. Now, Johnny wonders how many operations he needs to perform if he puts A in register and wants to get B at the end. To be specific, we want to print the minimum number of operations Johnny needs to perform. And if I cannot get B, then I would have to print -1. So there's an impossible case also. Okay, let's quickly generalize this problem. So they've given you a very big story. I'll just short it down in a very simple sentence approach. Basically, there's a number A and you want this number to convert to B. And to do that, you have been given 6 types of operations. Operations are, you can make A go from A to A into 2, A can become A into 4, A can become A into 8, or A can become A by 2 if again A by 2 is possible, as in you don't want to divide it by 2 if it's not divisible by 2. A can become A by 4 if it's possible, same thing, and A can become A by 8 if it's possible. So using these 6 operations only, you have to make A convert to B, and we have to make sure, what do we print? We print the minimum operations if so, or if possible, to make it happen. All right, make it happen. Now I'm saying if so, because if it is not possible, as in you cannot by using these operations make A into B, you also have to print a -1. So a no case is also there, and if yes, then print the minimum number of operations. Okay, let's do one thing. Let's take a very simple case over here. I'll take case number 5, 96 and 3. So you have been actually given the values A equals to 96 and B is given as 3. Now I can be very greedy over here and I'll give you my answer. I would make 2 operations. First operation would be, I'll divide 96 by 8. This is going to give me 12. And then I'll divide 12 by 4. And this is going to give me 3. So I divided by 8, divided by 4. So basically I used these last 2 operations. And these operations were again possible because it was divisible by 8 and also divisible by 4 next on. So I know I have done the operations right. I have actually gotten a 3. And I did how many operations? I did 2 operations. So this is actually the least. If you go back and see for test case number 5, the answer is 2. All right. So it's a very basic idea. Let's actually take a -1 case also. For example, 17 and 21. So if you have been told that A is equal to 17 and B equals to 21, you can just, I think, pause the video. You will not be able to come up with any operations by which you actually gain from 17 to 21. Hence, I think you can very well say that the answer is -1. So if you go back, case 3 has a -1 printed answer. All right. I hope the problem is clear. I hope the test cases are clear. Now let's do one thing. Let's actually discuss the time complexity in this. What is expected? Test is allowing me 1 second. And inside one test, there is test cases that are in 1000 order. So if I tell you that one test basically is giving me 10 raised to 8 number of operations for 1 second, and if operations are calculated now for every test case, then I'll be having something like 10 power 8 upon 10 power 3, that is 10 power 5 number of operations. Now this is not very huge. Why? Because if you look at A and B, can you see it's in 10 power 18? This is a very, very large number. If I take this 10 power 18 order into consideration, I can very well say that both being in 10 power 18 order, I cannot even picture to create a linear solution, something like O of A. That's not possible. You cannot go anything higher than that. By experience, we know that if we have such high constraints like 10 power 18 order, we are looking for either we create something like a log A solution okay, log base 2a solution, or a constant solution, or in something of that order. So we are looking for log or constant solutions, and we're not looking for anything linear. This is my expected time complexity. And now this is very fruitful because now I might restrain myself from running anything that is brute based. I don't want to actually might simulate the problem of how I would reach from A to B by various exploration of methods or paths, anything like that. This is something I'm not looking for. I might be looking for actually that is straightforward formula or some very acute mathematics which helps me achieve these time complexities. All right, and this is my hint one. Let us begin our idea. Okay, so now first of all, try to understand the operations that we have. What are they actually helping me do so? The number a goes from a into 2, into 4, into 8, by 2, by 4, and by 8. Now, if I look at 4, 4 is basically 2 power 2 only. 8 is basically 2 power 3, 2 can be written as 2 power 1. Then this is 2 power 1, this is 2 power 2, then 2 power 3. Now, looking at these operations and this 2 power also, is it safe to say one very important sentence over here? It's just saying that number a is being changed only by multiplying some power of 2 or dividing with some power of 2. To be very specific, a is being changed to something like a into 2 power x, where x is, this is again mathematics, see, minus 3, minus 2, minus 1, 0, 1, 2 or 3. If I say 2 power minus 3, that means 2 power, you can say 2 power minus 3 is basically writing 1 upon 2 power 3, which is writing 1 by 8. So if you multiply a by 1 by 8, that is basically dividing a by 8. Now again, condition is this is possible. That is something we can of course check that are we capable to do so. But then again, it is either saying I am multiplying by 2 raised to negative 3, 2 raised to negative 2, that is actually 1 by 4, 2 raised to negative 1, that is actually 1 by 2, so this is like 1 by 2, this is 1 by 4, 1 by 8. Now 2 raised to 0, that is basically 1, if you multiply by 1, that has no effect. Then 2 raised to 1, that is actually 2, 2 raised to 2 is 4, and 2 raised to 3 is 8. So I am only working with 2 raised to x component of the value of a which can be changed into. That means that if the number a and b, that is the original a and b, they are right now observed. Let's say this is a, let's say this is b, then I can be very smart and say one important statement that the 2 power in a and the 2 power in b is only something I can control. That means if I represent a where I have extracted all the power of 2 that could have come, then I can write a something like ra into 2 power x, and then similarly I can write b as rb into 2 power y. What does this representation mean? I'm basically saying that I've collected every 2 power x from a and I have kept this as 2 power x. And then I have other portion of whatever is left behind, whatever factors must be left behind, all of them have collectively been represented as ra, remaining a. And then similarly, I've collected all the 2 powers that are possible in b and I've named them 2 power y. And then again, y is some value. And then remaining whatever b is there, I'll call that rb. Now, by virtue, if I have made sure that all the 2 powers have been collected, then RA by common sense and RB, both of them are odd. Why are they odd? Think twice. If I'm saying that RA is the remaining portion out of which you have already extracted everything that had 2 power in that, then RA has to be odd, because if there is still some even nature to it, you can extract that 2 once more. So RA is by virtue odd. Similarly, RB is also by virtue odd. And now we have actually derived a very neat thing for ourselves. If you go back, we just saw that the operations only allow you to change the 2 powers in a number. They don't allow you to change the odd part that was there in the number. That effectively means that the RA value that you have right now in A cannot be changed to B if RA is not equal to B, because there is nothing that allows you to do that. The operations only allow you to convert this 2 power x to something that is 2 power y if possible, but RA cannot be changed to RB. No operations are available. That means I have actually figured out a -1 case right off the bat, that after I've extracted whatever is there as 2 power in A and as well as in 2 power in B, the remaining part in A should be equal to the remaining part in B. If it is not equal, if I write it like this, if it is not equal, then that translates to a -1 case right off the bat. And if it is equal, then all I'm trying to look for is how do I make sure this 2 power x converts to a 2 power y, so that since RA is equal to RB, how will I make this value equal to this value, effectively making A equal to B. Okay, and this is my idea. Now, this is case number 1. That is, if RA is not equal to RB, print a -1. And then we can move to case number 2. If they actually become equal, RA is equal to RB, then I'm looking to make 2 power X to 2 power Y. Now let's put small thought over here. You have the capability to make a number jump 2 power 3 maximum and actually get divided also by a number 2 power 3. So I think if we overall want to minimize the number of operations that we want of this kind, of this change of 2 power x kind, then we are looking for some sort of a greedy idea over here. Let's take a case. Let's say that right now you are at 2 power 12. And let's say you're trying to convert to 2 power 18. Now that means you're basically trying to make the power of 12 jump to 18. Now you have the power to make sure that you multiply 2 power 12 with 2 power 3. That's the largest you can go. If you do that, basically this power will turn to 15. Then again you can add 3 and this will turn 18. So do you think that by greedy nature, I have actually said that I will jump from 12 to 18 by doing 2 operations of the 2 power 3 multiplication kind? Yes, that is possible. Or indirectly, what I'm trying to do is, I'm trying to say, if you have this x value right now, that is the power in A, and you're trying to make it y, that is the power in B, then if I do x minus y absolute, I'll actually get the difference of what is the value or amount I want to cover, either in the back direction, as in if x is greater, then how do I want to move back? And if it's smaller, then how much do I want to move forward? And then I can try to divide it by 3. That is the largest in the left and right, both ways I could have gone, and seal up this value. Why seal this value? Because remember, the largest multiplication you can do is 2 power 3, but you can also do 2 power 2, 2 power 1. And in sense of division also, the maximum you can go is 1 upon 2 power 3, but you can also go 1 upon 2 power 2 and 1 upon 2 power 1. Which means, for example, let's say I would give you a straight answer. Let's say this would actually have been 20. So do this with me. You would have said, okay, 12 minus 20. This gives me basically -8. But I don't want -8 because I have the absolute value, so I would have done this 8. Now this 8 represents that, okay, 12 needs to jump a boundary 8 to go to 20. Let's do this by 3 and seal this value. This gives me 8 by 3, that is going to be 2 point something something. And if I seal this up, I basically land with 3. This 3 represents I would be doing 3 operations. And what those operations would look like? Tell me. You will do a 2 power 3. Then you will do a 2 power 3 again. And then you will do this 2 power 2 operation. And see, you basically would land up with how much value? This is going to be 2 power 8 overall. And this is finally what gets multiplied to 2 power 12, effectively giving you 2 power 20. In the reverse manner also, if let's say the example would have been something like this. Let's say you are actually at 2 power, for example, 17, and you're looking to go to 2 power 9, for example. So you would have said, okay, 17 minus 9, absolute, this becomes 8 again. So you would have said, okay, this is 8 by 3. Again, let's find the seal value. This is 3. What are the 3 operations? Now, because I want 17 to go to 9, that is decreasing, I would divide how much? I'll divide by 2 power 3. Then I'll again divide by 2 power 3, and then I'll divide by 2 power 2, which effectively means I'll divide by 2 power 8, making sure that 2 power 17 converts to 2 power 9, because 2 power 17 upon 2 power 8 will actually land with me 2 power 9. Okay, and this is why I said you want to divide by 3 and you want to make sure you seal it so that you get the effective number of operations correctly. And this is the whole main idea. You can give it 2 minutes thought, why did I do this by 3? Again, remember that the range that you have in which you can do the operations is ranging from -3 to 3. So everything that falls between that will also be covered automatically when you do a seal. If there is some extra point that is left, that will automatically get occupied in whatever case you could have picked up. Either that gets done by 2 power 2, or if 2 power 1, or 2 power -1, or 2 power -2. However that is going to happen, it will work out itself because you have taken the largest boundaries anyways. Right, so this is the idea. Let us run our idea once on one of the sample cases. Let's take up this case, 2 and 128. So you're basically looking that A is 2 and then B over here is 128. Now let's first try to figure out what is RA. So I can represent A as writing 1 into 2 power 1. So I've extracted everything that had 2 power in A. That means this part is RA. What is RB? I can write B as 1 into 2 power 7. This becomes RB. Now is RA equal to RB? Yes, it is. That means there is an answer. It's not -1. And what is this answer? Now we can figure out these two parts to work with. So I have 1 minus 7. Let's take absolute of that. That means this value turns out as 6. 6 by 3 seal gives me 2, which means I would be requiring 2 operations. Let's go back. Yes, this works out. And what are those 2 operations actually? You would have done something like multiplied by 2 power 3, then again 2 power 3. That means you would have multiplied with 2 power 6. Multiply 2 power 6 over here, you will actually get 128. Okay, I hope this helps. Let's take one more case and see a -1 in this order. Let's say something like this. You have 10 and 8. This is very nice. You have A equals to 10 and then B is equal to 8. Now A can be written as 5 into 2 power 1. I've extracted everything that is 2 power there. And then B can be written as 1 into 2 power 3. Now in this case, this is RA and this is RB. Now RA is not equal to RB. I've extracted everything that was 2 power in A and B also. Now RA, that is the leftover part, is not equal to the leftover part in B. Do you think now you can make A equal to B overall? It's not possible because this 5 will never convert to 1. There is nothing that is available to make this 5 to 1. That means I know I have a straightforward -1 case right from the start. And I can go back. Yes, the last case actually shows -1. All right. So the overall idea works out and we have made sure that we land at the answer. By the way, very, very quickly, because all of these operations that we are just looking to calculate and do are pretty much constant. You're not undergoing an actual simulation where you make A go to B in some sort of a step-by-step process, but rather you have quickly translated to what operations would have done if you make sure A wants to convert to B, again in the minimum order possible, because you made sure that you divided it by the highest boundary of 3. So it covers the best minimum operations anyways. All right. I hope this part is clear. Let us quickly move on to our code part and see how do we implement this out. So basically I have the same thing as I told you. I'll make sure how do I figure out RA and RB. I'll show you how that is. We take the test case input. We have A and B also as input. And then I'll declare RA equals to A right now. RB is B right now. Now what I'll do is till RA mod 2 is equal to 0, I'll divide RA by 2. And this is in a while loop. So this makes sure that RA number, which was actually A in the initial phase, has all the 2 parts gone from it. Similarly, RB, which was initially B, has all the 2 parts gone from it. Now RA and RB is exactly the remaining part in A and B had the 2 parts been removed. So now if RA is not equal to RB, I have a -1 case straight off the bat. And if that is not the case, then I can go in the else block. Now what is A? I have just tried to save a lot of variables basically. I'll make A convert to A by equal to RA. That basically means I'll make sure that I remove from A all that remaining portion. I remove from B all the remaining portion. So I have A and B as only 2 parts left. Now you have to figure out 2 power x. No, you have to figure out that x value. Remember, we want to work with x and y. So the best way to do that is we can make A as log base 2 of A. Now remember, why log base 2 of A? Very simple. If you have 2 power x over here and you take a log base 2 on this basically x comes out and log base 2 translates to 1. So if I want to extract what power of x or what power of 2 rather, I'm talking about, I can write A as log base 2 of A. B as log base 2 of B. Now A and B are exactly those x and y which you want to work with. And then this A and B have now basically become x and y. I can write it over here. This has now become x as explained in the code and this is y. So now you have absolute of A minus B or x minus y divided by 3, or rather not 3, 3.0. Why 3.0? Because I want to take a seal of that. So I want to make sure that I make at least one of these to either the numerator or denominator in decimal format. This is again a trick that we're using over here. The other trick of doing this would have been some different formula where you can take seal. That is also something you can Google out, but this is a very straight technique also. Just make sure you convert any one of them as a decimal part. This is 3.0. So now the denominator is decimal. Hence, this returns to me the correct sealed value. I store that in answer. That is the number of operations I want to make sure I do. And I'll print that it is the best possible. Now you can see all the long cases also, which I think were not easy to calculate with pen and copy, pass, which means my idea actually works. And what about the time complexity? we have actually come up with something that is almost next to constant. I'm sorry, I think I mentioned back it was exactly constant. It's not constant anymore, because what we would do over here is we need to extract the power of 2. So this would roughly translate to log base 2 of a, and then this would translate to log base 2 of b. Then over here, finding this a and b, or rather x and y value, is pretty much constant. All of this also is pretty much constant. So I have basically come up with only the time complexity that comes from that while loop, and that is O of log base 2 of, what's the max case? 10 power 18, which means this is order of 60. So order of 60 also not pretty large, but definitely it's not constant. So I'm so sorry there. We have a log base 2 power coming, and this is also fine because in expected time complexity, we had already discussed that we are looking for a log or a constant solution. So we did come up with some mathematics that was hinted over there also. So everything turned to be absolutely fine and checked out absolutely fine. What is space? Space is constant because I'm not using any extra array or anything like that to get my answer. All right, and this brings us to the end of our problem. All about mathematics over here. Just understand this 2 power, and I think this whole idea should be clear. And that is all that is there in this video. I hope you like it. Thank you for watching.